Hello everyone, my name is Gopi Krishna. Welcome to my YouTube channel. Today I am back with another coding interview problem, and this problem name is maximum subarray. Without any further ado, let's dive into it. Coming to the problem statement here, what the problem states is that you are given a array. As you can see here, this is one of the basic test cases. So, given an array, and you have to find the maximum subarray. Remember, and subarray can also be an array of the same length. So the subarray can even be empty array if the length of the array given as an input is 0, then the subarray is also of length 0. So the subarray definition states like that. So coming into the problem, it says that maximum subarray, so it should be contiguous. As the property of array, it should be contiguous. Now coming to this test case, I can see that by looking at the elements, you can say like after doing some calculations or going through the numbers, you can say that it is 6, it is in fact 6. So how we can get this 6? So by looking at the number here, there is there is one there is one answer here. There can be more than one, or any number of answers of the same number of same value. But what we care about is that one out of those, basically they will ask for starting index, I believe, like that. So they can ask anything, but you can return just in the basic case, or the general scenario, you can return the starting index. So now, as you can see here, it is 4 minus 1 2 and 1. The sum of this is 6 actually. If you consider these four elements, the sum is actually 7 minus 1, because one of them is negative, and again it is 6. So 6 is the maximum. If you go through all the combination of the array also, you will end up getting 6. You might get another 6 if there exists some if there exists that combination, but 6 will be the maximum here. That's what the point. There are many ways to solve this problem actually. One of them is simple known method, that is brute force. In brute force, what you will basically do is that take an index position, say like 0, and uh, then you have to add all the elements in the array till the end. Remember, it is an contiguous element to what you are required, not discrete values. It should be contiguous. So it should be starting at index 0. It should go from like 0 1 2 3, including all the till the end of the array. If you get the maximum out of those, then you can say something like that. Now if you don't know like how to visualize this, I have drawn a array grid here. So coming to the brute force solution, you can say like let's take whatever there in index 0. Then you will see that you will just put this in you will just put this in the final value, because there is only one element. Then the only element which can include is that only, whether it is positive negative doesn't matter. The only thing which we can include in the answer is only that element. Now coming to the second element, we'll just see like whether after including the second element and the first element, we got the maximum sum. If we don't get the maximum sum, obviously we'll stay with a 0 at 1. Next, likewise, you can go for the third element, likewise fourth, until n minus 1. As you can see, for each element you are iterating through the entire array. Then it will be of the complexity n square. So brute force is not affordable here. You can see the problem statement here, stating that it is easy and there are more likes, so you can go and attend this. And as you can see, there is only one element, then that element will be the output. And there is again 0 again, that will be the output, minus 1 and again minus 1. As you can see, again how much ever the value is, it doesn't matter, so you just have to return the same value if it is of length 1. We'll go with something called as Kadanes algorithm. Cadence algorithm just basically states that whenever you see an element, suppose that let's consider zeroth element, you just include, you will have two pointers or two, not exactly pointers, these are variables which stores the value, saying that which is a maximum subarray. If you'll start basically first store the zeroth element in both the values, suppose say like I will store minus 2 and minus 2 here first. Next, I will try to include 1, what is there in the next index, and I will see that whether by including this second element is better or not, by solving in the code that max of element of 0 and 0 and 1, or either max of 0. You'll see that in the code. Next, if you try to compare these two, then you can say like, if you compare this 0 and 1 element, you can see that it will become minus 1. And when it become minus 1, and if and the global variable will be somewhere lying in the global top position, so it cannot see the updation of the local variable. So whenever this local variable is greater than global variable, it will try to update it. And next, coming to minus 3, we will again see whether including this element helps us or not helps us in finding the maximum subarray, maximum sum in the subarray. So we'll just try to see that here whether it is feasible or not. By looking at that, we can see if we not include it, then it will be better. So what we will do, we will not include it, and I will just go something like that. Next, because minus 1 and minus 3 will be minus 4, so it is lesser than minus 1. So now when you see 4, by including this 4 and minus 1, you will end up getting 3, and only by including this element, you will get 4 at last. As you can see, it is 4. Now it will just take this element as it is more than that, as it is likely to get more than that. So so now coming to this minus 1, you have to include it. The algorithm states that take the sum of the take the either include this element or take the sum of previous maximum what you have got. So as you can see here, it will be minus 1, so it will become minus 3, because if you don't include, if you try to include that, it will be minus 1. So we'll update both the local and global value. And next, coming to 2, it will be 5. Next, we will update the global value. Next, coming to this one, it will be 6, and this will also be 6. Next, including minus 5, you end up getting smallest answer, so we will stay with the minus 6. We will stay with the 6, and then after once you pass some element and you didn't include it, the contiguous property has lost, so you can't include this. If you try to include this now, you can't say that this is better, so the global thing remains the same. So after looking at this, you will just return this file. The runtime of this algorithm is open. Next, the space utilization is only constants for this local variable and global variable. If I try to run my code, I'll just run my code. Just you will basically get an nums. This is the array, and if you will check that whether the length of the array is 0. If the length of the array is 0, you just return back, and if the length of the array is 1, you will just return the starting element, and then you will copy these both elements to this value, that is max value, that is the global value, and the local max, that is the local value, and you will just iterate through once of length n, so it will be it will be order of n. Now you can see that you will try to include the element which is present in present at that stage, or you try to include the element with the previous max what we have seen. So now see this, whenever the local max is greater than the maximum value, you will try to update that local max into the maximum value. Then you will return the maximum value. Yeah, that's it for the video, guys. If you have any doubts, please comment in the comment section, and I'll go through it. And thank you.